Welcome back. In this video we're going to explore our derivatives of our trig functions, and we can combine them with our other rules as well. To do so, we're going to have to take a look at two special limits. And the two special limits, what we're going to do is I have the limit as x goes to 0, the sine of x over x equals 1. That's going to be true if I take the reciprocal of that, or if I were to take and multiply the angle by something, like if I had the limit as x goes to 0 of the sine of, say, ax over ax. That's still going to be 1. With the cosine one, the limit as x goes to 0 of 1 minus the cosine of x over x, that equals 0. We don't use that one nearly as much because it converges to 0, so just kind of everything drops out. A couple of examples. I'm going to give you a few problems like this. If I have the limit as x goes to 0 of the sine of 5x over 2x, first of all, I'm going to pull that 1/2 out front. So I'm going to go 1/2 times the limit as x goes to 0 of the sine of 5x over x. Now what I need to do is I need this to be a 5. So the limit is x goes to 0, the sine of 5x over 5x, that's going to be 1. But I can't just randomly put a 5 down here. So what I do is I multiply this by 5 over 5. That 5 is a constant I can pull out front. This 5 I'm going to put down there in the bottom. So really this is 5/2 times the limit as x goes to 0 of the sine of 5x over 5x. Now this limit right here is 1. So this all converges to 5 over 2. Sometimes with the trig we have to go back to pre-calculus. Remember how it simplifies. If I had the limit as x goes to 0 of the tangent of x over 2x, again I'm going to pull that 1/2 out front. So I'm going to write it as 1/2 times the limit as x goes to 0. And this time I'm going to write it as the tangent of x, which is sine of x over cosine of x. And then also I'm going to multiply by the reciprocal of that denominator. So I just have a 1 over x down there. And then basically what I want to do is I want to switch the cosine of x and x. So it's going to be the sine of x over x times 1 over cosine of x. And now x can go to 0, because when x is 0, this is 1. Cosine of 0 is also 1. So it's 1/2 times 1 times 1, or just 1/2. And then sometimes algebraically you have to simplify the expressions down. This third example, I have 2x plus 1 minus cosine of x over 3x. The 1/3 can come out front again, so 1/3 times the limit as x goes to 0. And I'm going to very strategically divide both of these by x. I'm going to divide it up right here. So it's going to be 2x over x plus 1 minus cosine of x over x. So if I can divide both parts of that by x. Now, on this first part, the x's will drop, and that just becomes 2. This limit is 0. So now I can let x go to 0. When x goes to 0, that part's 0. This part is 2, so it's just 2/3. So we have a few problems at the beginning of this assignment on these limits, and you do have to know those limits. They do pop up on the AP exam every once in a while. And what that does is it leads to these derivatives. So the derivative of sine is cosine. The derivative of cosine is negative sine. Derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant times tangent, and the derivative of cosecant is negative cosecant times cotangent. You just need to memorize them. There's no secret to it. You just need to memorize them. We can combine these with all the other rules we've had. So like in my first example here, I have sine of x divided by 1 plus cosine of x. I've got to use quotient rule. And then once I use the quotient rule, then I'm going to have to go back and I'm going to have to simplify it based upon some formulas from pre-calculus. So y prime is going to be cosine of x, derivative of the numerator, times 1 plus cosine of x, minus derivative of the denominator, which is negative sine of x, times numerator, which is sine of x, over 1 plus cosine of x, quantity squared, multiply through by cosine, so y prime, now I'm just going to simplify, it's going to be cosine of x plus cosine squared of x. These minuses will drop out, so it's plus sine squared of x and that's still over that denominator. 1 plus cosine of x squared. Now, because cosine of x plus sine of x, right, cosine squared x plus sine squared x is 1, I can rewrite the numerator as the cosine of x plus 1 over 1 plus cosine of x squared. And one of them will drop out. So this will drop out with one of those. So ultimately, my derivative is 1 over 1 plus cosine of x. And oftentimes what you're going to find is that the hardest parts of these problems is going to be simplifying them algebraically and using your pre-calculus definitions. My next example is going to be x squared times the sine of x, and so I'm multiplying these together. So now I just need to use my product rule. So y prime is going to be 2x times the sine of x, and then plus x squared times the cosine of x. There's no simplifying you can do in that. You just leave it that way. And of course, we can take and make your right equations of the line tangent to the graph, or in the second case, we can do a normal line. A normal line is the same as the tangent line, except for it's perpendicular to the tangent line at that point. So it's done exactly the same way, except for take the negative reciprocal slope. So if I'm going to write the equation of the line tangent to the graph, I need to plug in pi over 4 in the original equation to put my y value. So y equals 1 here, and y also equals 1 here. If I go to find my slope, the slope is going to be the derivative, which is secant squared. At pi over 4, now here comes pre-calculus, unit circle. The secant of pi over 4 is square root of 2, so remember what this means is going to be square root of 2 squared. So that slope is just 2. So then for the tangent line, the equation of the line is going to be y minus 1 equals 2 times x minus pi over 4. And the equation of the normal line is going to be exactly the same, except for it's going to be the opposite reciprocal slope. So you take the opposite sign and the reciprocal of the fraction to do the normal line. Probably the biggest problem people will have is just that unit circle. If I plug in pi over 4 in the tangent, do I get 1? I plug in pi over 4 for secant, do I get square root of 2? And then also I can make you solve. I can find where the derivative equals 0, that kind of stuff. So if I want to find where the derivative equals 0 in the first part, I got to find the derivative. So f prime of x is going to be 1 plus cosine of x. If I set that equal to 0, then the cosine of x equals negative 1, and that happens at x equals pi. I don't ask you to generalize the solutions very often. It's not like I ask you to say, okay, well, what are all solutions? I just ask them, between 0 and 2 pi for the most part. And if I want to find the equation of the line tangent to the graph at x equals 0, I got to plug in 0 in the original equation to get the point 0, 0. And then if I plug in 0 into the derivative, if I plug in 0 into this derivative, I find that the slope is 1. So then it's y minus 0 equals 1 times x minus 0, or simply y equals x. All right, pre-calculus, unit circle, those are all going to be your friends, some of the unit identities. If you need help, there's a formula sheet that in a unit circle on the website that will help you out with all of these values. And I'll see you in class, and I'll clarify for you as much as I can.